Okay. Morning, everyone. My name is Martin. I am part of the MGnify team. My job there is to keep our service up and running. So pipelines is what I do most of the day. Today, I'm going to give a brief presentation of how we are moving away from a current screen. Share screen two. I think we are sharing.
Lovely, thank you.
All right. I'm going to talk about a little bit how we are moving away from our current workflow management into Nextflow and Core. So, brief agenda. I'm going to talk a little bit. I'm going to talk about a little bit about MGnify. What is MGnify for those that do not know it, and then how we adopt Nextflow and Core within our service. So in this quite busy schematics, you can see what MGnify is, all the data types that we support, and the data products that we produce. So MGnify is a platform, a resource that EBI provides for the community. It's a platform for the analysis and archiving of microbiome-derived data. So we basically provide a service to the community. Users sequence data from different biomes, as you can see on the top left corner over there. Sequence data, they submit the data to us, and we run a bunch of analysis pipelines through that data. Basically, we support 4 basic data types, which is basically meta-transcriptomic data, metagenomic data, assembled metagenomes, and amplicon or metabarcoding data. The different analysis pipeline that we have basically process that data and build taxonomic profiles and functional profiles of the data. We make the results available for the community. To the users. We also give users the ability to assemble the metagenomes if they wish to do so, which is a quite resource-intensive process. So not everyone has the ability or the compute power to do that. We offer that to the community. One thing that we do with those assembled metagenomes, for every single protein that we predict in those assemblies, we collect them all of the predicted proteins into one massive protein DB in a non-redundant way. So at the moment, is that the thing in the middle there is like nearly 3 billion proteins that was also made available to the community as like flat files on an FTP server. And the other byproduct of having those assemblies is that we build the assemblies and we build metagenome assembled genomes, which we collect in a biome-specific way. So we have collections of those MAGs or metagenome assembled genomes, and we also provide those to the community. Everything is accessible to our web interface, API, FTP servers, and whatnot. So as I mentioned, we support the analysis of 4 basic data types, which are amplicon, metagenomic, metatranscriptomic, and this is just schematic for the pipelines. I'm not going to talk into detail about the pipelines themselves, but they will be in a way I'm highlighting some of the shared components just to give you a sense of how everything is built on our side. This is the third kind of analysis pipeline that we have. This is for the assembled metagenomes, and it basically covers functional, taxonomic, and by sort of like system kind of way of predicting some bits on those assemblies. This is what the output of those results look like on our website. So we present some classic visualization charts and displays and whatnot for users to go and look at what the results look like for the analysis and whatnot. This information is also available through our web API for those that do not like to click around. This is like we want to get the results of the analysis and go there, and they can use our web API for that. So as you can imagine, keeping this service up and running with the amount of data we process every week, we do pipelines a lot. Our team is basically my sub team develops and maintains those pipelines, and our job is to keep them running, processing data as fast as we can. One of the things that we basically are shifting now is we are building more and more pipelines to tackle the complexity of data we're receiving, new sequencing technology, new approaches and whatnot. So we are building many more pipelines instead of having only like subcomponents. We are building more and more of those pipelines. I'm going to talk about briefly how Nextflow is actually helping us do that. As I was saying, this is like a punchline. Our team need to be, those pipelines to be stable. That is key. And they need to be versioned. We need to keep the ongoing development efforts and the maintenance effort to a minimum because we don't have a massive team. So we need to keep things in a sensible way. And because we need to uphold the highest quality standards as we can, because we are a public service, so we need to keep doing that. So Nextflow, NF Core and Bioconda fit this model and the mission that MGnify has quite well. But the title of the talk is Modernizing MGnify. Why? Because the pipeline that described at the beginning, they were built on using CWL, and we were using Toil as the execution engine for that. But we bump into many different issues with that. First and foremost, the stability with Toil and CWL was being a massive pain point for us. It was not behaving as expected in terms of the throughput, but also in the complexity of this pipeline. We were adding more and more tools to the pipeline, and CWL and Toil was just not working for us. The developer experience on CWL and Toil was not great. Debugging failing pipeline was a major issue. It was taking ages. And the onboarding of new people into the team was also something that was a bit tricky. So, and the last thing that I think is important when you run tens of thousands of pipelines every week is that you need to have a good, robust caching mechanism, because if one of those pipelines fail in the middle, you're wasting hours of compute time. If you don't have something that can retry things in a sensible way, you can just like overcome the common issues from HPC clusters. So we at that point we decided to move away from it, and we say, okay, what's out there, what's people use, and then the Nextflow basically became the most viable option for that. I think there are a few reasons for that. I think the Nextflow community by itself was growing a lot when we decided to do this, and we was like, I don't know, 8 months ago. EMBL-EBI was sort of like pivoting into Nextflow also, so that's strong in numbers. So being a small team within EBI and reusing that CWL kind of thing, being the odd one, the black sheep in the team, that doesn't make sense. When we were more invested in Nextflow, we were looking to NF Core and how they were doing things, because they sort of like solved one year division that we have, and that sort of like became the second panther. And then we ran a small prototype, and we were like, okay, let's explore Nextflow, how that works. And it became part of what the category of tools that I like the most, which are the things that just work. I just like using, I just work. So that was vital for us. So just a sneak peek of how our migration process was. So there was one pipeline that was specifically problematic with CWL. That was this pipeline that we used to annotate and build those MAC catalogs that we have. So we need to process hundreds of thousands of genomes, and we need to run all of those tools that I have listed in the README page of the pipeline. And just with CWL was becoming impossible. So I decided to rewrite it in Nextflow and see if I can actually manage to produce that. And it was fairly quickly getting new MAC catalogs out there quickly, because it was just working, everything went quite smoothly. A few of the lessons for those trying to see if they should migrate to Nextflow or not. This is like my team point of view. Nextflow operators are the bread and butter of your pipelines. Learn how to use them well. I think the new training.nextflow.io is a great resource for that. That was one of the things that got me invested. Syntax are hard to spot. USB code, Nextflow plugin for that. I think Paul was mentioning this morning that's going to happen that side. And then I think I've seen most team going into, okay, we need to use Nextflow because it's the thing that everyone uses and it seems to be working. And then, but they step away from NF Core because I think most people fear there's like too much complexity on that. But I'm after going through that process, I'm going to say that NF Core has a bunch of best practices condensed and distilled into code, good practices and documentation. So I strongly recommend everyone using Nextflow to sort of like peek into NF Core and see what they can use from there. So to wrap up, by adopting Nextflow, NF Core, and Bioconda, by just sort of like using NF Core, we are in a much better position to deliver our service. We can onboard new people quite quickly now. They become productive in just like days. And then what NF4 is bringing as a software engineer myself is that NF4 brings all the modern software development practices into the bioinformatics side of things. So we have a research team, we take those pipelines they develop in a select research in a way and just like make them production ready quite quickly, following those practices. Finally, I would like to thank my team. The poor guys have been hearing me part about Nextflow and for the past 8 months. Thank you guys. And that's it.